Hi guys! It's so good to see you again. We're here by my fish tank this week, just to mix it up a little bit. So I hope last week went well for you guys, and I'm really looking forward to the live lesson that I'm doing this week. I really hope to see you all there, and I would love your help getting my degree and finishing up my program so I can graduate and actually be a teacher. So let's just get into this week, okay? So we're going to talk about population dynamics. So we're going to look at how populations grow. So the first thing we need to remember is, what is a population? Okay? A population is just a group of organisms of a single species that live in a specific area. Okay? So we're going to start by describing a population. So to describe a population, we need to know 4 things. So we need to know the geographic range, the density and distribution, the growth rate, and the age structure. So we're going to get into what all of those things mean and start looking at and describing some populations. Okay, so first we're going to start with the geographic range, and this is just the area inhabited by a population. So for example, a population of bacteria is going to have a really small geographic range because even if there's a lot of them, they don't take up a lot of space. But something like fish in the ocean, they could take up a whole lot of space. They could be distributed throughout the entire ocean, or something like that where they take up a really big area. So their geographic range is going to be huge compared to something like bacteria. My dog has the zoomies, sorry. Okay. I'm just gonna wait. Okay, so next is density and distribution. So density is just the number of individuals per unit area. So for example, if you go to a meadow and there's a lot of grass, that grass is going to be very, very dense. It's everywhere. Especially if you look in one square, there's a lot of grass. Versus, let's say, deer, they're going to be a lot less dense, especially if you're looking in one specific square. There may or may not be a deer there. So they're going to be a lot less dense than something like grass. Okay, so then we have distribution, and this just describes how organisms are spread throughout their range. And we have 3 ways to describe this. So the first one is random. So the organisms are distributed randomly. For example, if you can see the fish in my fish tank, they're kind of randomly swimming about. They're not distributed in a certain order. They're not clumped together. They're just kind of randomly swimming around. So that is random distribution. And I'll throw up a little picture right now of an example with just some dots of how that looks. The second type is uniform distribution. So for example, penguins do this. They're distributed very evenly, they're organized, it's very uniform. And I'll throw up a picture of that one as well. The last type of distribution is clumped. This is when you have little groups of the species together, kind of clumped together in different clumps, groups, and I'll throw up a picture of that as well. So those are the 3 ways to describe the distribution of organisms in a population. Okay, so the third thing we need to look at when describing a population is the growth rate. And this is just if the population is getting bigger, smaller, or staying the same. So to look at this, we need to look at a few different things. So we can look at the birth rate, the rate of how many organisms are being born, the death rate, how many organisms are dying. So if the birth rate and the death rate are equal, then the population is going to stay the same amount of organisms are being born as are dying. If the birth rate is greater than the death rate, your population is going to be getting bigger, it's increasing, because more organisms are being born than are dying. And on the flip side, if you have less organisms being born than dying, so your birth rate is less than your death rate, your population is decreasing. And something else we can look at with growth rate is immigration and immigration. One with an I, one with an E. Immigration with an I is when organisms are moving into a population. Immigration with an E is when organisms are moving out or exiting a population. And we kind of talked about this before, but we're going to go over it again a little bit in terms of growth rate. So if immigration with an I is higher than immigration with an E, more organisms are moving in than are moving out, your population is increasing. And vice versa, immigration with an E is greater than immigration with an I, then your population is decreasing. More organisms are moving out than are moving in. So the last thing we need to look at to describe a population is called age structure. And this is just looking at the number of males and females of each age in a population. So how does a population grow? When we're studying it, what are we looking at? What are we looking for? The first type of growth we're going to look at is called exponential growth. This is just the larger a population gets, the more quickly it grows. This happens under ideal conditions. So when you have unlimited resources, it allows that population to grow exponentially. You have to have unlimited food, space. All of those resources need to be available. Okay, so I'm going to throw up a picture right now of what an exponential graph looks like. You can see that it's increasing really rapidly, and humans are actually experiencing this. So if you look at a graph of the human population over time, you will see that it looks like an exponential graph. The only time it decreases is during the Black Plague. Every other time in our history, we are increasing. So, can exponential growth last forever? Can a population have unlimited resources where it can grow and grow and grow and grow? Can that last forever? No, right? Those resources are going to run out. So sooner or later, that growth is going to slow down. And we're going to look at how that happens. So you have 3 phases of growth. Your first phase is exponential growth. So this is when there's plenty of resources and your population is growing. Your death rate is low and your birth rate is high. Our second phase is when growth slows down. You're still increasing, your population is still growing, it's just not as fast. And our last phase, phase 3, is when growth stops. So the growth rate stops and the population starts to even out. So the size is gonna stay about the same. Your birth rate and your death rate will be about equal at this point. So these 3 phases of growth that we just talked about all describe what we call logistic growth. And this is the growth that happens when resources are limited. And this is much more common. Most organisms grow and then they kind of level off. So although humans are in exponential growth right now, there will be a point where there's not unlimited resources anymore and that number is going to kind of even out. Okay? So a graph of a logistic curve is kind of shaped like an S, and I'm going to throw up a picture on the screen right now of a logistic curve. And I'm going to point out where phase 1 of growth, phase 2 of growth, and phase 3 of growth would lie on this graph. Okay? So there's many reasons why growth would slow down. Your death rate or your immigration with an E rate might increase. You have more organisms leaving the population, or your birth rate and your immigration with an I rate would go down. You have less organisms coming into the population. And this could all be due to those resources becoming more limited. All right, so the very last thing we're going to look at is called carrying capacity. This is the maximum number of individuals of a particular species that a particular environment can support. So if we go back and look at that logistic graph that we looked at earlier, you can see kind of toward the end that population number is going up and down a little bit, but it's staying around the same number. And that number is called the carrying capacity of that population. So we can see that this is the number that our population stabilizes at. So when you're looking at this type of graph, you can see growth starts to go up, the growth rate kind of slows down, and then it levels off. And the point it levels off is our carrying capacity. All right, guys, so that is all I have for the video lecture this week. If you have any questions, make sure to join us during office hours, and I really, really hope to see you during the live lesson when we talk about limiting factors for a population.